Okay, 6.1 key features of exponential functions. We're going to bounce from the PowerPoint to your worksheet, but you need that extra piece of paper. Okay, it's not. Okay, so this is what an exponential function looks like. If you look at the top, here's the parent function right here. So you have A. Remember that affects the rate of change, just like any other A on any other function we've had. You probably should write this, yes. You most definitely should write that.
What's it called?
Exponential growth and decay. What? Okay. It's the parent function. So f of x equals A, and that A can be plus or minus. So if it's a minus, we're going to reflect over the y-axis, isn't it? Just like any other reflection. B is the base to the power of x minus h. What does h do to a graph? Moves it which directions? Left and right. Always the opposite, correct? And plus k, what does k do to this graph? Up or down. Okay, so now I want us to look at this left graph first. If you notice, it crosses at when x is 0, y is 1. Because anything to the 0 power is what? 1, right? Anything to the 0 power, 7 to the 0, 28. How about 1800 to the 0? Every single one of those things is what? 1. Okay, so this is a growth function. And if you notice here, it says b is greater than 1. So the base is greater than 1. It is a growth function. See that? Now, so there's some things we need to notice. Our domain on here is all real numbers. I can put any x I want in there. I can put negative x's, positive x's, it doesn't matter. But my range, meaning the numbers are coming out of it, what numbers are coming out of it? Look at the picture. It's what? 1 0. Is it going below 0? No. Nope. And it's going to where? So greater than 0. Okay. Y is greater than 0. It cannot ever equal 0. Y is greater. Gosh. I told you guys I'm a mess today. Greater than 0. See that? Yep. Okay. So decay is B is between 0 and 1. That would be a proper fraction. 1/2, 3/4, 0.85. Okay, a proper fraction. Now the reason I say proper fraction, because what if I put 3/2? Is 3/2 greater than 1? Yeah. Yep, 3/2 is greater than 1, so that would be the left. It would be a growth. So if B is between 0 and 1, it is a decay function. This is growth. This is decay. Probably need to. Okay, but you notice the decay is still going through what point? 0, 1, isn't it? Because it doesn't matter if my base is positive or negative or a fraction. So if I have 1/2 to the 0, it is still what? 1. So when we have this equation right here, this is the shape we're going to be moving left, right, up, down. We're going to move which point? What do we call that vertex or that anchor point? We're going to be moving 0, 1 to where we need to have it. Make sense? Okay, if I put a plus or minus, right here, that is a reflection over
Does that say 0?
the y-axis. What?
Does that say 0, 1 on the first graph?
Yes. Okay. If this x, I said that wrong. You guys should have caught me. This is a reflection over the what axis? X. If the x is negative, it's a reflection over what? The y. Oops. I got too close to this arrow over here. Yep. So this is the one graph that it does make a difference. Some of the graphs we don't ever reflect it over the y-axis because we can do it with a moving left and right. Okay? But with an exponential function, things have to change for it to happen. Okay? But you notice on the left and on the right, isn't the right a reflection over the y-axis of the left? Yeah. So we can also, instead of making the x negative, we also can change the b and accomplish that sometimes too. Okay? So we'll just have to see what happens. But this is what you need to remember as we go. And we are going to be moving which point left, right, up, down?
Base.
The base. Okay? If b is greater than 1, it's going to be growth. It's going to go up. If it's less, it's between 0 and 1, it's going to go where? Down.
What if it's below 0?
If it's below 0, the base is into negative. We don't put a negative on the base. We do that with other things.
Oh, yeah.
Okay? So let's go to your worksheet that I handed out to you. So, the ones we do in class, I want you to signify that in some way on your worksheet. Maybe just put a NC next to it, and then that's an example. Or actually just put an EX on it, meaning it's a what? Example. Okay? So, and then that will be in your notes. Make sense?
Then we have to put it in our notes?
You're going to put it, you have a piece of paper right there. So you're going to put that in your notes. Really, Jaden? I said really? Okay, let me brighten it up a little. Is that easier to see? Maybe, maybe not. Okay, so number 1, we're going to look at it.
Does this have enough room to do it like on the...
No, probably not. Okay. Well, these are going to be in your notes. So you just have a piece of paper. You're going to have it in your notes. So, okay, so number 1, we're going to put that as an example in your notes. So we have y equals 5, 1/2 to the x plus 1 plus 2. Now, you notice I did not put the dot between the 5 and the 1/2. If you want to go put it there. If it's me on the worksheet, I just put a what on all of them? Parenthesis. It makes it much easier than that dot. Okay, so our parent function is y equals a b to the x minus h plus k. So the parent function again looks like this, going through which point?
0, 1.
0, 1. So 0, 1 is what we're going to eventually move left, right, up, down, okay?
How do you get 0, 1?
Because anything to the 0 power is what? 1.
There's something in the 0 power?
Okay.
I'm confused.
So our h is what? negative 1. Why is it negative 1?
Because that's
Two negatives.
Two negatives make a positive. My k is plus 2. So we're taking that anchor point, 0, 1, and we're going to subtract 1 from the x and do what with the y? Add 2. So 0, 1 is going to go to what? Negative 1, 3. See that? Now, is this going to be reflected right here? No. But b is 1/2. So is that growth or decay? Decay. Between 0 and 1 is decay. So I'm going to have you identify b is 1/2 and you're going to write decay. So that means instead of going up, it goes what? Down. Looks like that, right? Okay, so we are sketching these, not graphing these. I'm not making you do a table. The only point you have to know is this one right there. Understand me? Okay. Now there's some things we can do if you want to find your x and y intercept, which I'll show you in a second. Okay, so I know that this one goes through negative 1 and positive what? Okay, now, if we look at the parent function, that crook is right there at that 0, 1, right? So my crook is going to be right there at what? Negative 1, 3. Something I did forget to talk about is our range. Our range was greater than 0, wasn't it? So is y equals 0 a horizontal asymptote? Yes. Okay. So y equals 0, so you might want to add that to your parent function information. Y equals 0 is a horizontal asymptote. Since this went up 3, guess what's also going to happen to my horizontal asymptote? It's going to go up 3. So the horizontal asymptote was y equals 0. Now it is y equals what? 3. Actually, not 3. I said that wrong. It goes up what? 2. I looked at the wrong thing. Up 2. So 0 plus 2 is 2. So we're going to graph this. So at 2, there's a horizontal asymptote. So I should do what? Make a what? What am I doing? What's this dotted line? It's a horizontal asymptote, isn't it? Okay. So my crook is going to happen right here. And it's going to go from positive infinity. And go where?
Are we on the first problem still?
Yes, we are on the first problem still.
Alright, so
Stop that.
Okay. You're just going to draw an arrow. No, you want to show that shape though. Okay.
So we're gonna have like 2 graphs each.
No, there's one graph.
We just did like 3 graphs.
No, there's one graph.
So
Okay.
When was an example?
These are, this, Carly, is the parent function. This is the parent decay. This was our actual graph. So I'm drawing these so your brain can remember the shape. Okay, so let's do number, how about number 3? Now, we can't do example of every single problem you're going to get, but we're going to do example. Does that make sense what I'm trying to say? You just have to decode them, just like when we did parabolas or anything else. Okay, so 3. I know, please hurry. So y equals negative 1/3 2 to the x plus 2 minus 2. So again, my parent function is y equals a b to the x minus h plus k, right? It looks like this going through what point? 0, 1. And it has a horizontal asymptote where? Y equals 0. So we need to acknowledge all of those pieces. Okay. Say that again. H equals negative 2. K equals negative 2. So 0, 1 is now where? Negative 2, negative 1. How'd you get that, Cadence?
I subtracted 2 from x and subtracted 2 from y.
Exactly what you should do. Okay, so horizontal asymptote was y equals 0, but now it is where? Y equals negative 2. Again, subtracting 2. That k value, isn't it? There's one thing we haven't discussed. Oh, is it growth or decay? B is 2. So is that growth or decay?
Growth.
It's growth. But what does this do? Reflects it over what axis? The x-axis. So instead of going up, it's going to go like this.
Can't see it.
Like that,
Yeah.
right? Because the original went up like what? That?
Yeah.
Okay. So we know what it should kind of do, correct? Okay. It does decrease, but it's... Okay. B tells me it's a growth, yes? But why is it decreasing? Because of the negative. So can I have things tell me two different things?
Yeah.
Yes. But it's not a decay in terms of like this, is it?
No.
No. Okay.
Can you see your paper over to get the H?
Equals y equals 0. Because I can't have it both. Horizontal asymptote y equals, that's the parent function. This is all parent function information. It has nothing to do with this example. Okay. So I need my x-axis, right? And my y-axis. Probably should start with my horizontal asymptote, which is where? Negative 2. So that means everything is below negative 2, isn't it?
Yeah.
Because of this reflection, it's going down. Okay. Oh, wait, it's not. Oh, we've got to do something with this, don't we? Because it was negative 2. It was negative 2, negative 1, right? But it has to be reflected over what? Negative 2. So instead of being 1 above, it's going to be 1 what? Below. See how that reflection happens? Instead of doing this, like this, it's going to do what? Because it reflected. So this negative 2, negative 1 actually even changed further to negative 2 what? Negative 2, negative 3. And how did we figure out it was negative 3? Because we're up 1 from negative 2, so we have to be what? Down 1? Remember doing that in geometry where they had to be equal distance from the reflections?
Yeah.
Okay. So are we going to have to stop and kind of think about it and move it around?
Can we do another one like
Mm-hmm. Oh, like this one?
or like has a reflection?
Yeah, we'll try.
So we have to write all these ones out on our homework again?
All this?
Yeah.
Yeah, because if you don't do this, are you going to get it right? I mean, this right here,
No, like, you know how we're doing examples, like when we get to our homework later tonight, do we have to write each one down again?
no, you don't have to redo. That's why you're putting this on it, so you don't redo those.
So yeah.
Number 7? Yeah, we can do number 7.
She's more so than to shut up.
So that.
Ooh, crazy.
Now, you can always check these in your calculator. So, like, we just did number 3, right? So, if you go to y equals, I have other stuff in. Got all my inverse stuff in there. If I go to y equals, this is negative 1 divided by 3, right? Times 2 to the parentheses x plus 2. Oops, didn't put my 2 there, did I? Parenthesis minus 2. And is that kind of what ours look like? Yeah. So you can put them in your calculator and practice that. And that's using that. Okay. So you can check them. Okay. So number 7. Okay. So what do you want to do first? H and K? H is, K is, so 0, 1 goes to negative 2, 0. And again, how are you getting negative 2, 0? Subtracting negative 2 and subtracting 1, aren't we? Okay. Horizontal asymptote. So it was y equals 0. And now we're going to subtract 1 from it. So y equals negative 1. So if you want to start, you can start putting, like you could put your negative 1 here, couldn't you? Yeah, we will. I'm just saying. You could start that, right? So b is what? 1/2. So it's a decay.
Where'd you get 1/2 from?
Right here.
Oh, I was looking at the wrong problem.
Okay.
I thought you wrote down 2 H's.
Oh, no.
Now I realize that
Are we
after a
supposed to be
second.
doing domain?
Domain and range, we can. We'll go back to them. I totally forgot about them. Thank you.
We don't have to.
Okay. Domain is not going to change. It's my range that's going to change. Okay. So what else do I need to talk about on here?
It reflects.
It reflects, right? Reflects over what?
X. Doesn't it reflect over the horizontal asymptote too?
Yeah, that's the x. When we say x-axis, it's actually reflecting over the horizontal axis. Does that make sense? Okay. So this point was negative 2, 0, correct? It was here. But since it's reflecting over this horizontal asymptote, instead of going up 1, it's going to go what? Down 1. So this negative 2, 0 is actually negative 2 what? There's negative 1,
Negative 2.
negative 2. So it's actually going to be right here. So then it goes what? There.
Are you doing right?
Just a second. So the domain is still all real numbers. What is my range? Look at your picture. What's your range?
Negative
Oh, not
infinity to
this.
positive infinity.
Nope. Range is what's coming out of it. It's everything less than what?
Everything less than -1.
-1. So y is less than, not equal to, -1.
So it could
It's that
be-
horizontal asymptote that tells you your range. So let's go back up to the ones we did already. So this was number 7, right?
Yeah.
Okay, so number 3. So number 3. Again, domain is all real numbers, but what is my range?
Y is less than -2.
Y is less than -2. It's the horizontal asymptote. Okay, so number 1.
Wait, what was it?
Y is greater than what? 2.
Why is that one greater than?
Because it's above. I'm kind of cut off. Because it's above 2. See that?
So you think?
Jaden, what was your question?
I got it now.
Okay, so the horizontal asymptote is going to be your cutoff, right? So you just need to decide if it's above it or below it. Guys, did 5 change anything? Nope. Did 1/3 change anything? Nope. Because I'm not plugging points in, am I? Now, if I wanted to be more exact, that would change the rate of change.
I don't want to be more.
I don't either. Okay, now 8. Why did you want to do 8? Just because it has the 1/3 or 1/2?
My favorite number, Miss Smith.
8 is your favorite number. We'll do 8, and then we'll move on writing equations.
And just put us in the other column. Move on there.
Yeah, we hadn't done any from over there, had we? Okay, so 8. Yes. So when I'm writing this, I'm writing y equals 1/2 parenthesis 5 to the x minus 1 minus 2. So h, 1. Not negative this time, right? Okay,
2, -2.
-2. So 0, 1, and where do we get 0, 1 from?
That's the base.
Okay, it's a parent function, and everything to the 0 power is what?
1.
1. Okay, so what are we going to add to 0? 1, and get 1. And then 1 minus 2 is going to be -1. So we add 1 here and subtract 2 here. Okay. Horizontal asymptote. Y equals 0 was originally. Y equals -2. B is what? 5. So is it growth or decay? Growth. So it goes up like this, right? And it doesn't reflect this time, does it? So do I have anything else I have to count for? No? We'll do range after we graph it, okay? You can do range first, but sometimes it's easier to look at it
How do you get 5? Like b equals 5.
because it's right here.
Oh.
B is the base of the exponent. Okay, so it goes through where? 1, -1. My horizontal asymptote is at where?
-2.
-2. And it goes what direction?
Up.
Oops. Goes up. So what is my range this time?
Greater than -2.
Y such that y is greater than -2. Now remember, in the textbook, if you look at it, they may do that interval notation. So it would be parenthesis -2, comma, infinity. Wouldn't it? If you're doing interval. Because neither of them are included. So these shouldn't take you a lot of time. If you try to shortcut it and not do the work, it's going to cause you issues. Make sense? go through, state all the stuff, and draw your picture. It went very smoothly, didn't it?
For
Okay.
15 through
So now we're going to go backwards. Yes.
If it's growth, then y is greater than, if it's decay, then y is less than.
Unless it's reflected. Because we had a growth that was reflected, didn't we? Yes, see this? On number 3, it was a growth, but it was reflected. So you can't, does that make sense, what I'm saying? Okay, so now we need to write the equation, so we're gonna work backwards. So we're gonna look at this, and we're going to figure things out.
How do you write all day?
Hmm?
Never mind.
Okay. You're confusing me. Okay, first of all, what do you notice about this graph?
It's going up.
It went up, right? So the horizontal asymptote is what?
It's greater than.
Greater than 2.
How about just y equals what? 1. See how that is there? Okay, this isn't exact, is it? No. Where you see the cricket? Looks like right there to me, doesn't it to you? Wait, it can't be right there. Never mind. If everything went up 1, sorry, because it was 0, 1, right? And now it is at, if it goes up 1, 1 plus 1 is what? 2. So the y is 2. So we don't know the x. So we go y is 2. What's your x? I'm not liking these.
0?
I don't
I
think
guess
that's
we
what you have
can't
to
do
do.
them then.
Yeah.
So then I just did it graphing. It have to be
That's a
0.
good idea, Sarah.
I know.
What?
Well, if y is 2, actually, let me do this on the right one. Let's go y is 2, not x is 2. No one caught that. Y is 2. What's x?
That's what we're trying to figure out.
I know, but I was going x was 2.
Oh, I was.
So y is 2. What's your
2.5.
x? About 2.5. I agree with that. You guys agree with that?
Yeah.
It's almost 3, but it's not quite 3, is it? Because I wanted to put it right here. Okay, so 2.5 would be 5 halves, wouldn't it?
I was thinking 0.
Your x was 0. That would be down here.
Then wouldn't your y be different too?
No, because y is 1. Yes?
Y is not.
Okay, your horizontal asymptote is at 1. So everything went up what? 1. So if it was originally 0, 1, what's 1 plus 1? 2. So you go on your y is 2. What is your x? I'm thinking 5 halves. How about you guys? Okay. So I now, is it reflected? No. So we now have y equals, and I'm going to let you guys put b for now. We're only going to worry about the h and the k today, okay? I want reflection, like reflected over the x-axis. Does that make sense?
So like a plus or minus from the
Mm-hmm. Okay. And then it's going to be x minus what? 5 halves. Plus,
2.
not plus 2, plus 1.
How?
Yeah, if you could
Because
do
everything
that,
went up what? 1.
That's confusing.
That's not very confusing.
We're only worried about which HK and reflections right now. Okay? We'll worry about everything else later. So let's do another one. They kind of twist your brain a little bit because you got to think backwards, right? Okay. So where did everything go down to? Where's your horizontal asymptote now? -2. See that, Jaden?
-2.
Okay. So it's y equals -2. So everything went down what? 2. Okay. So I'm going to go y equals, so 0, 1, change to, I subtract 2, right?
Something -2.
Okay, No. Subtract 2 from 1 is
-1.
-1. But we have something else going on. It's also reflected over what? It's also reflected over the x, right?
So B is negative.
So
We know it's reflected.
because it's going down. So it was, if this would be -1, right? It was here, now it is at negative what? 3. Because it's 1 up, it has to be 1 what? Down. So I shouldn't have done that. So this is like this, right? So -3. So now I come to -3, and what is my x?
-4.
-4. That was nicer, wasn't it? Wasn't 5/2, was it?
Yeah.
Okay, so,
Still lost.
Wait, how did you
I don't
get?
understand.
okay,
Oh, never mind.
I had to go down with my thing. I shouldn't have done it up there. So,
How are you
This-
deciding?
just a second. Okay, the horizontal asymptote, does everyone get the horizontal asymptote is a -2? Yes, okay. So, this is reflected down, isn't it?
Yeah.
Yes. When we said everything went down 2, we took 1 minus 2 and got what? -1. So that means it was at -1, but it reflects over what? -2. So what is the difference
When the bell
between
rings, all
-1 and
juniors
-2?
Freshmen
1.
need to
So
report
instead
to
of
the
going up
stage,
1, we go
turn in your
down what?
laptops
1.
and your
Which is
chargers.
what?
There will
So
be a
that's where my
girls' high
-3
school
came
basketball
from.
meeting.
So I go,
Current
why
eighth
is
graders through
-3?
11th graders
Go over, and
today
what's your
right
x?
after IAP.
-4. So this is my h and my k, isn't it? Okay. So we have y equals, now in order for -b, good job, because it's reflected, right? X
4,
plus 4
3.
minus 3.
What's -2?
Yeah,
Yeah,
on the
how'd
last
you
one
get-
it was +1. Because you took the
It'd be
y.
Oh, it is -2. Sorry. Thank you.
And why did our 4 turn? Oh, yeah. So they're
Reflected. How did we get -4 again? Like, I get that.
Okay, so wait, okay, everyone listen again. The horizontal asymptote was -2, yes?
yeah.
Okay, so if I take original point 0, 1 and I minus 2, I get what? -1. So that new horizontal asymptote is at -2. -1 is up 1. So when I reflect it, if I went up 1, I have to go what? Down 1, which gives me -3. So y is -3. I go over till I hit the graph, and what is the x? Negative. Yep. Normally we go x, then y. This one we have to go y, then x.
How'd you get +4? for
Because it's the equation is x minus h,
Oh, yeah.
so minus a negative.
Should give us like opposite or odds.
I would like you to do all of them, and we can go over them tomorrow. Okay? If we need to spend the time fixing, I want you to try all of them. There aren't very many. It just looks like it because there is
There is like 20 to do.
not 20.
Yes, there is.
There is 12.